Good morning. In our last class, we have learned about electric potential and hope you all have understood it. Today we will learn about electric potential difference. The definition of electric potential difference and electric potential are somehow equal. So let us see the definition of electric potential difference. It is defined as the work done per unit charge in moving a unit charge from one point to other, isn't it? It is similar to the definition of electric potential. Let us see it again. It is defined as the work done. Okay, it is defined as the work done per unit charge in moving a unit charge from one point to other point. Okay, from one point to other point when a charge move. Okay, and the charge will not move automatically, some force will be there. What force I have told you? And it is electric force will push that electron from one place to another, so it has covered some distance. So when a body is pull or push, and that body if it moves from one place to another, then work done is happen, isn't it? In class 9 we have got it, that when a body is pulled or pushed, then it moves to a certain distance, that amount is called as work done. Okay, so same thing, it is defined as the work done per unit charge in moving a unit charge from one point to other point. So let us go into the depth of the electric potential difference. Actually, what is the difference? Actually, the electric potential difference. So suppose I have taken a simple electric circuit. As from the diagram, you have easily able to know that this is a battery, this is the connecting wires, and this is the electric current by convention, and this is the bulb, and this is a one closed circuit. Now when it is a closed circuit, then what will happen? The current is moving, isn't it? This electric current by convention is moving from this positive charge to negative charge, isn't it? And electron are moving from negative to the positive, which I have already discussed. So when the electron is moving from this one and this one, this end to this end, then what type of electron? What type of current is? It was electronic current, which is actually the electric current. Okay, and this one is the conventional current. So we will represent it as a electric current by convention. Okay, so now the electric potential difference, let us see what is this. Suppose let us assume that the positive charge, okay, is moving from this positive end to the negative end. Okay, we are assuming that the positive charge is moving. Okay, in actual sense positive charge does not move, the holes or the void actually the move. Now what is hole or what is void, you will able to study it in the higher classes. So now let us just assume that the positive charge is moving. Okay, we are assuming it, that the positive charge is moving from the positive end to the negative end. Now when the positive charge will move through this wire along with the current, okay, then what will happen? The bulb here will glow. Thereafter, then this bulb will release some heat energy. Okay, now when this bulb will release some heat energy, then this positive charge will lose some of the charges, isn't it? Means if I would say as an example, suppose from here 10 positive charge is moving, then in this negative terminal it will less than 10, suppose 8, it will go inside it. Now why I am telling from this positive charge, the positive charge is moving, because positive charge and positive terminal, it will repel. Okay, thereafter this negative terminal, this negative charge, it will attract a positive charge. Thereafter when it will enter the positive charge, then again it should repel. Now inside the battery some chemical reaction are been going on, which we will study in the higher classes. Now that chemical reaction will bring or push the positive charge to this positive terminal. Then again same scenario will occur here. Is it clear? Now you see, when there was the difference, means again I am telling from 10 positive charge, when it is entering 8 or something less than the 10, then there is some difference. Actually that difference is called as the electric potential difference, and there should be some difference, then only there will be the flow of current. If there will be no any difference, there will be no any flow of electric current by convention. Is it clear? Now let us see one very simple example. Suppose let us take two tank, this A, this B. You can see I have drawn here to show you that these are suppose the water level, means suppose water, and this also water. You see the difference in the height. See, can you see? So here the level of water in tank A is more than level of water in tank B. Have you seen? Now see, there is some difference. Have you seen in the height? Now by nature, you see, you have experienced the thing. You see, when there is high, when there is low, then if I connect here one pipe, then this water will move this side, isn't it? Okay, from high to low. You see, from high to low the water is moving. Now this will continue flowing. Okay, the water will continue in flowing until this height and this height will become same. For example, this one, you see, when the height of this water level is same, then the flow of current is the flow of water is stopped. Okay, thereby we can see that here from high to low, means always the water flow from high to low. Similarly, if you imagine that the waterfall actually fall from the high line to the low line, isn't it? In the same way, the current, you see, suppose if we see here, that here you see positive charge was moving from here to here. Now this portion is the high potential of positive charge, means high potential. Okay, high potential. Do you know what's the meaning of potential? It's the stored energy, stored. Okay, high, here high potential is there, then here low potential is. The current always moves from the high potential to the low potential. Since this is the low potential, so electrons are moving from low potential to the high potential. Is it clear? Now if the current question comes, that how the current moves from how the current moves in the electric circuit. You can add this also. That current also moves from the high potential to the low potential. Okay, this current means electric current by convention. Okay, and the electron moves from low potential to the high potential. It's very similar to this, you see, high, low. And when it will stop? When the level is same. Means when the electric current will stop when the both sides will be same. Okay, both same, high potential, low potential. If it's same, then there will be a stop of flowing current. Is it clear? So now let us see the last part, and which is also the very important one. that if 1 joule of work is done in moving 1 coulomb of electric charge from one point to other point is called 1 volt. Now if the question come, what is 1 volt? Okay, then you can say that if 1 joule of work, okay, if 1 joule of work is done in moving 1 coulomb of electric charge from one point to other point, means again same thing, if 1 joule of work is done, okay, from moving 1 coulomb of charge from one point to other point, then that is called as what? 1 volt. Okay, again I'm telling, if 1 joule of work is done in moving 1 coulomb of electric charge from one point to other point is called 1 volt. Okay, thank you.